So today we're going to practice two z-tests, one for a single proportion and the other for a single mean. Now last week we had looked at some z-tests for a single proportion. The procedure that we're going to be doing for a single mean is the same process, just a different set of equations for talking about means rather than a proportion. Um, but really, our main goal is to be able to use the graphing calculator to help us with these calculations. If we take a look at the equation sheet, this is linked at the top of today's lesson page. Right there, this is a slight variation of what we had in our previous unit with confidence intervals. We still have those confidence intervals down here on the bottom left for each of our four cases, but we're going to be looking right now at the bottom right, which has our four z-tests for our tests of significance. And today we're going to concentrate on a single proportion and a single mean. Okay? This is very similar to what we saw with the z-score calculation back in the first semester. We have our x bar, which is our sample mean, minus mu, the population mean, divided by our measure of standard deviation, which is the standard error, which we use with confidence intervals. You see that back over here. But again, I would focus on these calculator commands. It's a lot easier to use and a lot easier to interpret. So that's really going to be our goal for today, is familiarizing ourselves with those. So let's take a look at our first problem here, which is the proportion. It says a statistician read that at least 77% of the population oppose replacing $1 bills with $1 coins. To see if this claim is valid, he selects a random sample of 80 people and found that 55 were opposed to replacing the $1 bills. And we start by identifying the null and alternative hypotheses. So remember that the null hypothesis always has some form of equality in it. A lot of times that's just an equal sign, but it could be greater than or equal to or less than or equal to, but it needs to have equality in that null hypothesis. So here we are told you're always going to be able to determine what that null hypothesis is based off of the language in the problem. The statistician read that at least 77% of the population were against this. So that means that that population proportion P, it could be equal to 77% or it could be greater than that. So we have greater than or equal to. You always need to put this proportion as a decimal, so 0.77, which means that our alternative hypothesis needs to be any other direction that's left. Okay? In this case, that would mean that the population proportion is less than that 77%. Okay? So all three cases are accounted for here. The two numbers are either equal, one's greater than the other, or the one is less than the other. Okay? So this alternative hypothesis, okay, with that less than sign, that's only a single direction. So this is a one-sided alternative hypothesis. Now, using the calculator, that doesn't really matter that we recognize that. I mean, it's important for us to see that. But if we were to do this by hand with the equation and a z-score chart, being one-sided or two-sided influences what we do at the end of this process. Okay, are we looking at a single side of that bell curve, or are we looking at both sides and we have to multiply by 2 if it is a two-sided? We'll see that in our next problem. So we're going to calculate the z-score, find the p-value, compare to that alpha level of 0.05. So let's go to the calculator. So on the graphing calculator, we're going to go to Stat and over to the Tests menu. And for a single proportion, we're looking at number 5, which is a one proportion z-test. Okay? So p sub 0 is the p-value that you started with in the null hypothesis. Okay? Actually, I shouldn't call it a p-value. It's the population proportion. Okay? And both of our hypotheses they're always about the population value. So this is 0.77. Okay? In the null hypothesis, we feel that we have at least 77%. The x value is the raw number, meaning that we had 55 people who were opposed to this change, and the total sample size was 80 people. Okay, this was back in the problem. Now, this last thing, we need to tell this calculator if it's a one-sided or two-sided test. Okay, the default setting is not equal to, which would mean it's a two-sided alternative hypothesis. That's not what we had. We had that p was less than 0.77, that null value. So we need to go over and hit enter to have it less than that p sub 0 value. And then we'll go down to hit calculate. And you can see that it does calculate that p hat, that sample proportion for us. So it's 68, almost 69%, when really that null hypothesis was 77%. So this is less than that null value, which is what we would expect. We are testing to see if it's significantly less. We see the z-score there of negative 1.75. So if what we expect, 0.77, is at the center of that curve, we are 1 3/4 standard deviations less than that. And you see the accompanying p-value there, 0.0397. Let's just make it easy and say that it's 0.04. So we'll go back to our notes here. We have a z-score of negative 1.75. We are smaller than the center. And the p-value, we'll say, was about 0.04, which is less than 0.05. So p is low. We reject this null hypothesis, which means that we feel we have evidence, significant evidence, that less than 77% of that population are really against making this change. Okay? Reject the null hypothesis, accept the alternative. All right. Now, let's just say this was a two-sided alternative hypothesis. Okay? The calculator would do this for us, but if we were doing this by hand and we got this p-value of 0.04, now, again, that represents down in this tail. If it's two-sided, we're not saying that it's less than, we're saying it's less than or it's greater than, okay? It's not equal to. So we don't care which tail it is, and we need to consider both. So that p-value would be doubled in that case, meaning it's 0.08, and that actually totally changes our interpretations because now we're no longer less than 0.05. Okay? If you had told the calculator that this was a two-sided test and made that p not equal to p sub 0, then, the calculator will do that for you. But again, if you were doing this by hand and you got this decimal off of the z-score table, then you would have to double it because you have a two-sided alternative hypothesis. Let's try a problem with a mean here. In this problem, it says that a researcher wishes to test the claim that the average cost of college tuition at a 4-year public college is greater than $5,700. She selects a random sample of 36 schools and finds the mean tuition to be $5,950. The population standard deviation we are given, 659. So, the null and alternative hypotheses for this one. This wording is a little bit more difficult to interpret here. It says the researcher wishes to test the claim that the average cost of college tuition is greater than $5,700. Okay, that is actually telling you what the alternative hypothesis should be. Okay, that it is not $5,700. Okay, so what we are going into this with is saying that the null hypothesis, I'll write the null up here, we're testing to see if that null hypothesis is equal to $5,700. Okay, so in this case, we're going to say mu, the population mean, is equal to $5,700. Okay, it's always some form of equality. We feel that there is evidence. We're testing this claim that it's actually greater than $5,700. So the alternative hypothesis will be mu is greater than 5,700. Okay? Now you could say that that null hypothesis, if we want to account for all three possibilities, that should really be less than or equal to rather than just equal to, and that's okay. You could set it up like that, but a lot of times we will just put an equal sign because the other direction doesn't make a whole lot of sense. Okay, we have our sample here with a mean that is greater, so that's the one that we are interested in. Okay, so this we're testing to see if this alternative hypothesis is greater than that $5,700. Okay, so this will be a one-sided alternative hypothesis. So notice, let me make a note here that this sample value that we have of 5,950, that does not appear in the hypotheses. Okay, the hypotheses are always made with respect to the population. Okay, so it's that accepted null value, and you still have that null value in the alternative hypothesis. It's just either bigger or smaller or different than. Okay, but you never have that sample value in the hypotheses, because again, your end goal is to be able to say that one of these two things is happening in the population. Right. So let's go to the calculator to perform this test. And again, we'll go to stat, over to tests, and for a mean, it's our very first option. Z-test means a single mean. So you do have two options. We saw this with confidence intervals. We can have the calculator pull data from the lists, or we can just tell it all the numbers that we need, and that's what we have here. So we're going to go over to stat, and then we have our null value, in this case was $5,700. Our standard deviation was provided for us, that was 659. Here is the sample mean. Okay, so we did a sample of 36 people. We got that average tuition was $5,950. So this is where that appears. And this was across a sample of 36. Now, for this alternative hypothesis, we feel that it is greater than that null value. Okay. So we change it to that, hit enter, and go down to calculate. And in this case, we have our values here, a z-score of 2.28 if we round that up, and a p-value of about 0.01. So we'll go back to our problem here. Z-score, we said that was about 2.8. I'm sorry, 2.28. And our p-value was about 0.01. Okay, and this was a one-sided, so that stays the same. The calculator would do that for us anyway, so that is less than 0.05. So that means we reject the null and accept the alternative. Okay? And in plain words, that would mean that we do have evidence that this mean tuition, this average tuition, is actually greater than the 5,700, okay, that was advertised. All right, so there are two additional problems left that I would like you to practice. Okay, this is your homework for tonight. Here we're talking about an average length of a prison sentence for white-collar crime. And then this one we're looking at another proportion. 73% of first-year college students identified themselves as being very well off financially as an important personal goal. Okay, so I'd like you to read through these, create the hypotheses, set up the test, solve it, and give an interpretation of your results.